we might get this done. 23 says -2 less than x plus 4 less than 7. Okay. So what we are supposed to do is simplify this by getting x by itself in the middle. You guys know what I mean by the middle? So there's kind of 3 sides. Instead of like 2 sides like normal, there's 3 sides. There's the left side, the middle, and the right. So to solve for x, we got to get x by itself in the middle. So guess what I'm going to do?
Subtract by 4.
Okay, I'm going to subtract by 4 on all sides, like -4, -4, -4, like that. What is -2 minus 4? -6 less than, what's going to be in the middle?
X.
X less than 3. So basically x can be any number between -6 and 3. Like if you make up a number between -6 and 3, it should work up here. Like 1. 1 plus 4 is 5. 5 is less than 7. 5 is greater than -2. Anyway, just proceed. So that's basically how you do 24. Unfortunately, I'm not going to give you any time right now at the moment to work on the evens, so we're going to just jump straight into page 165. Yes, we're not grading now.
Thank you for your grade.
Are they both due Thursday?
I already mailed it to you.
Yeah, we're going to try to get them both done by tomorrow. So really quickly, you guys remember what we did yesterday? It's called conjunctions. And what word was used in conjunctions? And what was the symbol for and? The A. Almost, yeah. And then, okay, today we're doing something called disjunctions. Instead of the word and, it means or. And instead of the upside down V, it's a V.
It's just a V then.
Okay. The difference between a logic or and a or that you would say normally, usually when we use the word or, we mean it's this one or this one, like one or the other. But in logic, or can means it's one or the other or both. So if I said, I don't know. You guys are Oklahomans or you are from Bartlesville. So it kind of sounds like I'm saying one or the other is true, but really on the or statement, they can both be true. Yeah, if I said you guys are Oklahomans or you're Americans, that's true, even though both are true. So that's a little bit different than the or we're used to, but it's pretty close. Okay, so here's an example. If you don't want it directly on you, if you just open it halfway, it might blow to the side.
I'm actually hot.
Okay.
I'm actually always hot, so.
Okay. Okay, so just like yesterday, there's kind of 3 different cases. Case number 1, if they're going in opposite directions, let's do this. X is less than 1, looks like that. X is greater than 3, looks like that. If it's an or, what numbers would work for this? Well, if I plug in like 0, does 0 work in this statement? Is 0 less than 1 or is 0 greater than 3?
Yes.
Yes, because it works in this one. Is 4 less than 1 or greater than 3?
Yes.
Yes, because it works in that one. So the only thing that doesn't work is like
2,
these numbers. So our final answer actually looks exactly like the floating lines. Yesterday, when we had an and right there, it's what do they both have? What numbers are less than 1 and greater than 3? Nothing. So yesterday it was no solution. Today it's all of these and all of these. Just everything not in here, basically. That's case number 1, and that's probably the most common case, is when they're going opposite directions like that. Case number 2, let's say x is less than 1 or x is less than 3. So they're going the same direction. So x is less than 1 or x is less than 3. What numbers would work in that situation? Would 0 work? Is 0 less than 1 or less than 3? Yes. Would 1 work? Is 1 less than 1 or less than 3?
Yeah.
Yes. Doesn't work in this one, works in this one. Does 2 work? Is 2 less than 1 or less than 3? Yes. Does 3 work? Is 3 less than 1 or less than 3? No. So really it's just everything from here on. So really it's just less than 3. Okay, here's kind of the quick trick with OR. If it's covered by either of the lines, it's going to be part of the answer. Why didn't I put an open circle in here?
Because 1's less than 3.
Because 1 still works.
Yeah.
Okay, so I don't need a circle here. I need a circle at 3 because 3 doesn't work. This is not, 3 is not included. Alright, so that's case number 2, they're going the same direction. Case number 3 is where they're going the opposite direction and they cross. 1, 2, 3, 1, 2, 3. X is less than 3 or x is greater than 1. What numbers would work in that case?
2.
Would 2 work? 2 is less than 3, 2 is greater than 1. Would 1 work? Is 1 less than 3 or greater than 1?
Yeah.
Yes. Would 0 work? Is 0 less than 3 or greater than 1?
Yes.
Yeah, it's less than 3. Would 4 work?
No. Or yes?
Yeah.
Is 4 less than 3 or greater than 1?
Yes.
Yes. What wouldn't work?
Nothing.
Everything works.
Whoa.
Okay, if you look at these lines, what are they not covering?
1.
Nothing. They're covering
Wow.
everything.
Oh, yeah, that's smart.
So any number you can think of has to be less than 3 or greater than 1.
How would you write the arrow in the key?
Okay, how would I graph it? What do you guys think?
Open circle. Oh.
A solid line from left to right.
Just one big open circle.
So just one solid line. Everything. If I wasn't graphing, how do you think I write the answer is everything? Okay, it's called all real numbers, which means every number, basically.
The R thing. Yeah.
Or the fancy R stands for all real numbers. Okay, so yesterday's weird one was the no solution. When they used the and with, like this situation was no solution. Today's weird one is all real numbers. Sometimes you can get every number. Okay, guys got it? Ready to go?
Oh, yeah.
Okay, number 1 says, in a conjunction, inequality statements are joined by the word and. Conjunction was yesterday, that was and. Number 2, in a disjunction, inequality statements are joined by the word or. O-R. Okay, 3 and 4 we did not talk about, and I'm not going to make you have to know this, but the solution to a disjunction is called the union of the two sets. So just put union for number 3. In a disjunction, in an or statement, the answer is the union of the sets. And on number 4, it says the solution to a conjunction, it's called the intersection. Intersection. Yeah, because it's kind of like, you know, on the intersection where the 2 roads meet, that's where both of them are at. Well, in an and statement, it's where both of them are at. Union. Okay, 5 and 6, you guys should know this. The symbol of a V indicates a disjunction. And number 6, the symbol of the other thing indicates a conjunction. Okay, number 1. So I'm going to start with the floating lines. It's got 2 and 5 on number 7. So I'll just do 1, 2, 3, 4, 5, 6. X is less than 2, or X is greater than 5. So what numbers are less than 2 or greater than 5? This was kind of like our first example. You guys remember it?
All numbers.
No, not all numbers. All the numbers,
Every other number.
But 1 through 3.
all the numbers are over here, and all that. It doesn't matter that they don't have anything in common. Because it's an or, it can be this one or that one. They don't have to be together. So it's just basically that. That is the answer. So everything less than 2 could work, and everything greater than 5 could work. Number 9 has 2 and 5 also. 1, 2, 3, 4, 5, 6. So this one says x is greater than 2 or x is greater than 5. What numbers are greater than 2 or greater than 5?
2 greater than 2.
Yeah. If it's covered by either of the lines, it's going to work. So everything past 2 is going to work. So basically it just simplifies to x is greater than 2. You guys remember what the answer to this was yesterday when we said and? And means where they both are, and they're both like here and beyond. So it was, on the end it was greater than 5. Okay, number 11. Number 11 has -4 and 4. -4 actually. -4, -4. I'll make this one small. -5, -4, -3. X is less than -4, looks like that. X is greater than -4, looks like that. So what could X be? Everything but 4. In other words, it's like X is not equal to -4. You guys remember what that graph looks like?
Yeah, one open circle that was.
Open circle at -4 and everything else is covered. What if one of them had said X is less than or equal to? What would that answer be? The circle would have been closed. So what would this answer been?
All closed.
All, it'd be this, well, you wouldn't need a circle at all, you just draw a solid line to be all real numbers. Okay. 13. Alright, 13, we can't solve it because it's already solved, but we can simplify it a little bit. If x is not equal to 6 or not equal to 3, what could x be? We're not supposed to graph these, but let me graph it just to help us think a little bit. X is not equal to 3 means anything but 3, or x is not equal to 6, anything but 6. So what numbers are covered on that? What? Is 6 covered? Is 6 not equal to 3? This line is x is not equal to 3. This line is x is not equal to 6. Or sorry, this line is.
So it's also all.
Yeah, any number that you can think of is either not equal to 3 or not equal to 6, right? It's going to be one or the other. Any number you can think of is not equal to. All numbers are covered by these two things. So it is all real numbers. So you can put you can write all real numbers, or you can put the fancy R down. This is not actually a graphing problem. I just did that to help.
Oh.
None of these are graphing problems after 11, after 12. Okay, 15. This is, we did a lot of these yesterday. So we just got to solve these separately. Or 3y minus 5 is greater than 2. All right. What do we need to do to the left side?
X. 6.
Add 6. What's negative 6 plus 6?
0.
0. Or what do I do to the right side?
Minus 5, add 5.
Add 5 is 15. Divide by 3 is 5. Okay. Just like yesterday, when you go to do these on the evens, you can just stop right here. But since I'm helping you on the odds, we're going to simplify it as much as we can. What numbers are less than or equal to 0 or greater than 5? Well, all these numbers are less than or equal to 0, or all these numbers are greater than 5. So it's just like number 7, just like my first example. If they're going opposite directions, just everything gets included. It's in this one or it's in this one, it's just, they all get involved. So really, it is just all these numbers and all these numbers together. So this does not simplify, basically, is what I'm telling you. This is as simple as it gets, yeah. Yesterday, every single problem simplified. Some of these don't simplify any more than that. 17 says 2b minus 6 is greater than or equal to 14. Or 8b plus 2b minus 3. Okay, it says 8b plus 2b minus 3, so what should I write down? 10b minus 3 is greater than 27. Paxton, what should I do on this one? On the left one over here. Add 6, that will make 20, and then what? What do I do here?
Divide by 2.
Divide by 2 makes 10. On this one we would add 3. That makes 30. What's 30 divided by 10?
2 or 3.
3. Okay. So b is greater than or equal to 10, or it's greater than 3. So what is that? So if this was an even, you could stop here. But what does that simplify to? Greater than 3 or greater than or equal to 10?
So it's just greater than.
Yeah. All these numbers starting back here are covered, right? Since it's an or, you start back there. So really, it just simplifies to x is greater than 3. X plus 6 is less than or equal to -9. Or x is less than 6. That's not going to be too hard. Alright, so the left one only needs some work. So what's -9 minus 6? -15 divided by 3. Do I need to switch the inequality? No. Divide by 3, divide by 3. Okay, and this other one doesn't really do anything, right? It's already simplified. Okay. How can I simplify this statement? X is less than or equal to -5, or x is less than 6.
X is less than 6.
Right, everything from here on, here and smaller is just going to work. Basically, it's just x is less than 6. Two more. Am I going too fast? Yeah, I'll slow down a bit. You don't have to copy everything down that I write down because you guys know how to like add and subtract on your own, so you don't really need to see everything. This 21's a little bit trickier though. Go a little bit slower on that one. Or 3x plus 6 is less than 8. Alright, what should I do on the left side? Whoops, I didn't write the right symbol. What's that supposed to be, a less than?
Minus. Wait.
That's right.
Greater than -2.
Oh, you're right.
Let's do that. There we go. Now what should I do on the left side over here? Exactly. Subtract 3. Now what?
-2.
Divide by -2, so x what?
X is greater
Hmm.
than 2.
Less than.
Yeah, you divide by negative. What's 5 divided by 2?
1.4.
Well, it's 2.5, right?
2.5.
I'll just leave it as 5 over 2. Negative divided by a negative divided by a negative is a positive. This one looks more normal. Subtract 6 is 2. What's 2 divided by 3? Two-thirds. All right. How does this simplify? Well, if I put this on a graph, 5 over 2 would be like 2.5 basically. And 2/3 we'll say is over here somewhere. So it's less than on both of them. So it looks like this.
So it's less than 5
You're not drawing this, are you, Nancy?
No.
Okay. I was gonna say it's a lot of extra work that you don't have to do. Yeah, so basically everything that's smaller than 2.5 is gonna work, or 5/2. So that is the simplified answer. Okay. That was like a record timing
Yeah,
for me to
that's
finish that one.
23.
Oh, 23. I forgot I got one more. Darn. I was gonna have a record and then.
Not quite a record.
You gotta go fast. Just give us the answer.
Okay, we can skip one step on 23. If we have m's on both sides on 23, what should I do first? On the left, what should I do first on the left on 23? Subtract 4m. So I'll do that step in my head. So it's -4 less than or equal to 2m minus 8. And the right side has the same problem, so let's do that. All right. What should I do about the m's on the right one? Add 3m. So it'll be 1 is greater than or equal to 8m minus 3. Okay, so I want to get m by itself over here on the right, so I'm going to add an 8, divide by 2, what's another way of saying 2 is less than or equal to m? We're used to this one more, right? So that might help us. Let's see, over here I gotta add the 3. Oh, this is one that people get this one wrong a lot.
Divide by 8.
People would put 2 for this answer, but it's not 2.
It's 1/2.
Yeah, 8 divided by 4 is 2, but 4 divided by 8, yeah, if you reduce that, that's 1/2, right? So 1/2 is greater than or equal to m, or m is less than or equal to 1/2. forgot to point something out. Something is different about this problem besides the fraction. Yeah, there was an and. I didn't point that out. So if this is an and statement, what are we going to use?
Something.
What numbers are less than 1/2 and greater than 2?
Oh, it's
No.
nothing.
Nothing.
All that.
By the way, they also slipped an and in on number 22, was it?
Yeah.
So be careful on 22. Actually, I said you guys didn't have to simplify those, did I? So
Yeah.
I guess it won't kill you. All right, now you got some time. Quite a bit. We went fast today. So try to get all those evens done.